Okay. Who developed the long form of the periodic table?
Was it Bohr?
Pardon?
Or I think it was Bohr, but I feel like it's Mendeleev.
Mendeleev, yeah.
Yeah.
Right? Keep on
Yeah.
noting down some important points, right?
Mm-hmm.
This question. Yes. Here is the electronic configuration n-1 d1 to 10 ns1 to 0 to 1. Is a characteristics of which type of elements? Lanthanoid, actinoid, rare metals, or transition elements? Do you remember this, or should I discuss it in detail something?
Is it the rare earth metals?
I'm not getting you.
Rare earth metals? Because it's in the S.
No. Actually,
Okay.
the last electrons are entering into the n-1 d subshell.
Okay.
So it's a d block element, and d block elements are called
They're
as transition elements. Yeah, d block,
Okay.
right? So you can note down this electronic configuration for the transition elements.
Okay.
Okay.
n-1 d10. Okay.
On moving to from left to right in the transition metals, their atomic size
Decrease.
decrease. Yeah.
Yep.
You know why?
Is it because there's more protons?
Number of shells remains same, but
Yeah.
nuclear charge goes on increasing, right?
Mm-hmm.
So attraction goes on increasing and the size decreases, right?
Right.
Okay.
Number of atomic number 33. 5?
Yeah. In which group it will be there? Do you know how to find out?
Isn't it like you go backwards from like...
No,
Is
not
it
like this. Not like this.
36?
I will tell you in a particular way, right? There's a particular method how to find out, right? It's a group number is 15, but I will tell you how to determine this value. This is the 33 number, right? So you can write the electronic configuration for 33. Argon complete. Then we have 4s2, 3d10, and 4p3, right? So you'll find here that the outermost shell is a fourth shell. So its period number is equal to 4. Period number is equal to 4, right? And block is equal to p block element.
Right.
And the group number will be equal to, if the electron goes into the p subshell, last electron in the p subshell, then it is the n plus p, n plus s plus, sorry, s plus p, now find it like this, s plus p plus 10. Means outermost shell is fourth shell, s electrons and p electrons plus 10. Total is equal to now 2 plus 3 plus 10. And that is equal to now 15. That is the correct answer. Right? It means in the periodic table, this element belongs to the period number 4. Period number 4, block is P, and group is equal to 15.
Yeah, because there's 10 in the middle, right?
Yeah.
So like you just kind of add the 10 for the transition metals.
Are you getting me?
Yep.
Okay. Now, Yeah, in the periodic table, let's go down the group. In the fluorine group,
Is it stability increases?
what?
Stability of hybrids will increase?
Uh, do you have certain logic behind this, or you just
I,
guessing?
I'm kind of guessing because that
Okay,
was one of the answers on the homework, and
okay,
I was like,
okay,
what? But that was the answer. It's like,
okay.
okay.
One thing. Be very, very, very specific regarding this. That there is no guesswork in chemistry,
Yep.
right? One thing, you have to be very, very logical, and particularly when you are appearing for the NEET examination, the question is not based on the on the guess part only, right? It is right, very specific, very scientific, very technical. Right? I'm not I'm not making you like afraid of it, but the fact is this.
Yep.
So fluorine group means I'm talking about the fluorine, then I have chlorine, then bromine, and then iodine. Right? These are the elements here, and the answer is of course B here, right? That I have shown here.
Okay.
Ionic radii increases. Think about this: F negative, Cl negative, Br negative, I negative. Right? And how do I know this? See now.
Because isn't it because the shielding increases?
Yes, as you get down the group, the 1s2, 2s2, 2p6. Its electronic configuration is now neon complete and 3s2, 3p6, right? And for this, it's a argon complete. Then I have 4s2, 3d10, and 4p6. So as you go down the group, you can see the number of shells are increasing. So the size will increase. But if you're looking at the first option, the stability of the hydrides means what? Combined with the fluorine, chlorine, bromine, and iodine, right? So as you go down the group, what will happen? As you go down the group, what will happen? The size will, atomic size will increase, right? As the size increases, the bond length will. Yeah, tell me what will help to the bond. What will help? Yeah, bond length
Will be longer.
will become more, right? As the bond length increases, the bond strength will
decrease.
Yeah. Bond strength will decrease, right? And so the bond dissociation energy will
decrease.
Yeah. Bond dissociation energy decreases.
So if A said stability of hybrids will decrease, then it would
that
be.
should decrease over here, right? So that is why it's the wrong answer here, right?
Okay.
C and D are wrong. Electronegativity decreases here. Enthalpy of ionization also decreases here because of increasing size.
Yeah.
Right. So the correct answer is the B option. Correct answer. Right. Getting me?
Yeah.
Okay. Oh, very general question. The most important step in the development of the periodic table was taken by?
Was it Dalton?
No, Mendeleev.
Oh,
He first of all made the long form of the periodic table.
Okay.
Right. Okay, now colored salts are found by?
Actinoids?
No, these are the transition elements.
Okay.
I tell you what is the basic fundamental here, because that is more important. Without understanding, it will be of no use. See, if I talk about the iron salts, let it be FeCl2, right? Ferrous chloride. This is green in color, right? And if I talk about ferric chloride, FeCl3, right? It's a rusty brown color, rusty brown, this color. And what about copper? Copper sulfate solution?
Wait.
Blue. Right? For the elements like manganese, they form all of the pink color. And the nickel compound, like we have nickel sulfate or nickel chloride, they have a bottle green color. Exactly like this one I'm writing right now. Right? Hello, are you getting me?
Yeah, yeah.
So they have a different color here. Now, question arises here, what is the cause of their color? Right? The cause is they have D subshell, right? Their last electron is having the D subshell. 1, 2, 3, 4, 5, and 6. It's a D subshell. And this D subshell is large and diffused, right? It splits up into two different energy levels here. When it makes a bond with the chloride, sulfate, or any other thing, it splits up into two different energy levels. And this is called as an T2G, and it is called an EG orbital. Some electrons remain in the ground state, and some in the excited state. Some orbital remain empty also. When radiation falls upon this, electron jump from lower energy level to the higher energy level. Is this clear up to this point?
Yeah. So like because they're jumping, they create the light.
So we are providing some energy. E is equal to h into nu. Out of total energy, some energy is being used in the excitation, and the remaining energy is coming out. So E dash is equal to h nu dash, right? So we can say E dash will be less than the E, or I can say nu dash will be less than the nu. It means the transmitted frequency is different from the incident frequency, and that is why the color is appearing based on the reflected frequency. It is not upon the incident. Incident radiation is the white light, but out of the white light, some frequencies are absorbed and remaining are coming out. The complementary color will be appearing. That is why these transition elements, their compounds are colored.
I see.
Getting this? Should I proceed ahead?
Yeah. Mg 2s2.
Very good. It's lithium with the magnesium, right? They're diagonally placed in the periodic table, right?
Yeah. But like other than that, doesn't it have to do kind of with like 1s2 and then 2s2 and then you get
nothing to do with it. They are diagonally placed in the periodic table, so they show similarity in their physical as well as chemical properties.
Oh, that's interesting. Okay. Radius of isoelectronic species.
What do you mean by the word isoelectronic?
Is it like they have the same number of electrons?
Yeah. And they have the number of shells also, right?
Yeah. So then, isn't it A? Because, like, if you have, like, a plus charge, then it's
then what will happen to the nuclear charge?
I mean, sorry. If you have, like, a negative charge, then it's higher, and a bigger radius, and if you have, like, a plus charge, then it's a smaller radius.
Okay. I give you one answer here, right? Basically, answer I have shown you, right? But I'm explaining here. Suppose I'm giving you this nitrogen 3 negative. How many electrons does it have?
It would have
10. Yeah, 10. So the electronic configuration is the 1s2, 2s2, and 2p6.
Yes.
Right? Protons are equal to 7 here. And now if I talk about the O2 negative, atomic number is equal to 8. Again, it has same electronic configuration. right?
Mm-hmm.
And if I talk about the fluorine, F negative here, nuclear charge is equal to now 9. It has the same electronic configuration. So with increase in the nuclear charge, what will happen to their size? Will it increase or decrease? You tell me. Yeah.
You would increase because like you have, especially for N, like you have more electrons than
No,
you
electrons are
do.
same. Electrons are same. They don't have more electron, less electron. Isoelectronic means they have same electrons, same number of electrons.
Right,
Yeah.
but then for like the radius, like they have a different number of protons, right? So there would be a different attraction. So like ones with the more protons would have a smaller radius.
So as the nuclear charge increases, the radii will
Increase.
decrease. Attraction will increase.
Oh, sorry.
I
Yeah.
can say the
Decrease.
nuclear charge per electron will increase. Electrons are constant here, right? 10.
Mm-hmm.
But earlier for the nitrogen, this is equal to 7. For the oxygen, it is equal to 8 by 10, right?
Right.
For the fluorine, it is 9 by 10. You can say the nuclear charge goes on increasing per electron.
And yeah.
As the nuclear charge increases, the attraction will increase and the size will decrease. Right? Getting
Yeah.
me? So it is the B
Mm-hmm.
option correct answer.
Yeah.
Okay. Yeah, no, this one.
Largest ionic trees. Which would be CS. Cesium.
Yeah, cesium. As you go down the group, ionic radii increases. Right?
Yeah.
Okay. Elements of which family forms anions most easily? Halogens, alkali metals, oxygens, or nitrogen?
Alkali metals because they attract electrons.
Do you know what are alkali metals?
Isn't that? Oh no, those form cations.
Yeah,
Sorry.
yeah, that's
Okay,
right.
sorry. Never mind. So halogens.
Yeah. Which can you tell me the name of the halogens?
Like fluorine and chlorine.
Yeah, fluorine, chlorine, bromine, iodine,
Bromine.
right?
Yeah.
So they have tendency to gain electrons, right?
Yeah.
So they will have tendency to gain electrons. Any element, right? Fluorine can easily gain electron to become F negative ion. Right? They can easily form the anion.
Maximum
first ionization potential. What is the approach for such type of questions? What is your approach? How are you coming to the conclusion? You tell me.
Okay.
Yeah.
So like what I was thinking, because like manganese is like a d orbital, so that's not going to have a high ionization potential.
Don't you think that all of these are d block elements?
Looking at it now, yeah.
Yeah, all of these are d block. So your logic is not.
That doesn't work.
Getting me, Jana, right? So it is not a guesswork, right? We have to be very, very specific in your concepts. Very clear. I'm not I'm not making you a fear of, right? I'm not making you afraid of it. But let us develop the concept, right? So that when you are appearing for the NEET or any other entrance examination, you must be having a very clear concept. See, the point is, see, manganese, of course, it is just guess, and it hit right. Okay. Basically, what is ionization potential?
That's like the potential energy of like how much you would have to put in to
Two.
take away the
Very good.
electron.
To take away the outermost electron,
Yeah.
it means what is the concept here? This is the electron, the outermost shell, right?
Mm-hmm.
And there's a nucleus over here. And between the two, there is some attraction here, right? So when you're providing
Yeah.
energy, the electron is getting out,
Yeah.
right? How much energy is required to eject out the most loosely bound electron from an atom? That is called as the ionization energy or
Yeah.
potential. It means there is some force of attraction which is holding them together, which keep them together, and that is the electrostatic force of attraction. You know the Coulomb law?
Mm-hmm.
You know,
Yeah, I've heard it.
between the two opposite charged particles, the attraction is called as the Coulomb law,
Mm-hmm.
and that is directly proportional to the charges of the two particles and the radius of the two, right?
Mm-hmm.
So stronger the attraction between the two, more enthalpy of ionization is required, right?
Mm-hmm.
And that factor is, number one is the electronic configuration. If you check out the electronic configuration of manganese, can you tell me the atomic number of manganese?
Um, looking at it is
Yeah, it's
25.
35. So if you write electronic configuration, it's the argon complete, and then we have a 4s2 and 3d5.
Yeah.
And in that case, you find here that they have half-filled electronic configuration.
Right.
And
And
half-filled,
so like that's kind of like what I learned was that a half orbital and a full orbital are like kind of complete in the way that they're like the electrons are like
yeah. So
the most content in being that way, so it's the hardest to take them out.
yeah, of course, you're right here. So they are stable here, right? And
Mm-hmm.
to eject out from the stable electronic configuration, we require a very, very large amount of energy.
Mm-hmm.
That's why D is the correct answer here. Okay.
Mm-hmm.
I think this way we can develop the concepts, right? Now, the reverse question. Lowest first enthalpy of ionization.
Lowest enthalpy. Um, that would be wait. What?
Check out
CA.
check out on the in the electron in the periodic table. Do you have the periodic
So
table in front of you?
yeah, I do.
Yeah.
Cause like I'm between RB and
Yeah.
rubidium and calcium,
Yeah.
because like rubidium you'd be going back
Down.
like a whole period, but then calcium you're still in the same period
Yeah.
for that one.
So, which is the final answer now?
Gonna go with rubidium. Is it not D?
Yeah, D. You're right.
Okay.
It is D.
Okay.
It is D.
Okay.
As you go down the group, it is a maximum number of shells here, right?
Okay.
So rubidium has the largest size. No. Yeah, calcium is 20. 20 is it is 37, right?
Yeah.
37 means it is a 5s1.
Yeah.
Okay. Yes. The correct order of ionization enthalpy for comparing the carbon, nitrogen, oxygen is,
C.
how do you come to them? What's the
Because like if you look at it like oxygen has like the most electrons, and then nitrogen has less, and then carbon has less electrons, so it's like
okay?
harder to take
Okay,
them
okay.
out.
Its answer is the A option, correct answer. Now I'll explain, right? How it is
Hmm.
A. Carbon atomic number
Is 6.
6. Electronic configuration 1s2, 2s2,
2s2.
2px1 and 2py1, right?
Mhm.
2pz is 0. And nitrogen, atomic number
7.
1 is 2, 2 is 2, 2px1, 2py1 and 2pz1, right?
Mhm.
And for the oxygen, this value is equal to 8.
8.
Its electronic configuration is now 1s2, 2s2, 2px1, 2py1, 2pz1 and 2px2 here. Getting me?
Okay.
So don't you find that this is a half-filled electronic configuration?
Oh. Okay.
And so it is more than nitrogen also, as well as for the oxygen also. And oxygen will have more than that the carbon because of the high nuclear charge here. Getting me?
Mhm.
Hmm?
Right.
So it is the A option correct answer. So many factors you have to keep all together, right?
Okay. Electron gain enthalpy values for halogens are the following.
Mhm.
So B, because like you're gaining like you're
Okay,
gaining the enthalpy,
do you
right?
understand what you meant by the word electron gain enthalpy?
Isn't that like when you do with like absorption of energy, so you have to put energy in to take it out,
No,
right?
no, 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 not like this. I tell you what is this
Okay.
electron enthalpy, right?
Mhm.
Wait, let me explain it here. What is this electron gain enthalpy? Suppose we have an atom A and I'm adding one electron to this. It becomes A negative, right?
Mhm.
In the gaseous state. When we add electron here, it is associated with some amount of energy release. We call it the electron gain enthalpy. Energy is released, so I'm using a negative sign here, minus x joules. So electron gain enthalpy is the amount of energy released when an electron is added to an isolated gaseous atom. When an electron is added to an isolated gaseous atom, right? This energy released is called as electron gain enthalpy. Am I clear?
Amount of energy released when an electron is added to an isolated
Gaseous atom. It means more the attraction for the electron, more is the energy released, right? So it depends upon number one, size of an atom. It depends upon size of an atom. You can see that if the size increases here, then the inner shell electrons will not allow the nuclear charge to go out effectively, because that electrons will be shielding the nuclear charge. So electron cannot reach out so effectively. As the attraction decreases, the enthalpy of ionization will decrease. So we can say the electron gain enthalpy is inversely proportional to the size of an atom, right? Second factor is the nuclear charge. Basically, there is an attraction between this nuclear charge and the electron, right? And this is a Coulombic force that operates over here, and that Coulombic force is directly proportional to the charge on the nucleus and the charge of the electron upon r square. As this nuclear charge increases, the attraction will increase. More the attraction, more energy will be released. So I can say electron gain enthalpy is directly proportional to the nuclear charge. Getting me? Getting me or not?
Yeah.
So next is we have the electronic configuration. All those atoms which are either half filled, either they are half filled or they are completely filled, they are stable, and to add electron to them will be difficult, and for that electron enthalpy will be 0. They don't want to add more electron. They are stable with their half filled or completely filled electronic configuration, right? Getting me?
Yeah.
So if we compare this with this question now, let us see now. Here we have one exception case here. It's a fluorine, then we have a chlorine, then we have a bromine, and then iodine, right? As you go down the group, the atomic size, tell me what happened to the atomic size?
It becomes bigger.
It becomes bigger, so the attraction will decrease,
become small. Yeah.
So the answer should be C option, correct answer? Yes or no?
Yeah, because there's a bigger size, so then it's easier to take away the electron, and so the energy release will be more than the energy that you put in to take out.
Okay.
I guess.
It should be C option, right? But actually this is not the correct answer. The correct answer is A. Reason, this is all clear that as you go down the group, the size increases and the attraction will decrease. But if I compare the fluorine and the chlorine, nuclear charge is 9, chlorine is 17, so it's a 1s2, 2s2, and 2p5, right? It's a neon complete 3s2 and 3p5. In the second shell, fluorine has a second shell, right? In the second shell, how many electrons can be accommodated easily?
Isn't it 8?
Yeah, in the first shell 2, and second shell maximum electrons can be 8 here. 1, 2, 3, 4, 5, 6, and 7, right? It means incoming electron can be only one can be adjusted easily. But this is the second shell, and second shell is very small. 2p subshell is very small. As this is very small, the electrons are very congested, and that will repel the incoming electron. There is some repulsion between the already existing electron in the second shell and the incoming electron.
So then why not for the first shell, because that's even smaller and can only hold 2 electrons?
It's already fully filled. Electrons cannot come into the first shell. They will come to the second shell only, outermost shell only.
Okay.
Right? But that is small in size, and due to that the electrons which are already present, they will repel the incoming electrons. So If I compare it with the chlorine now, see, chlorine atomic number is 17. This is the third shell, and the third shell, second 1s2 is complete here, right? Second shell has 8 electrons complete. 1, 2, 3, 4, 5, 6, 7, 8. And third shell. In the third shell, can you tell me how many electrons can be accommodated?
Another 8.
Not another 8. It is a 3d10 electrons can also be accommodated here.
Oh, so
right?
18.
It means total electrons can be 18 here, but only 7 are filled only. And they are all scattered 1, 2, 3, 4, 5, 6, 7 only. It means still it has bigger size. Lot of space is empty. Lot of space is vacant right now, and the incoming electron can be easily adjusted here. There will be no repulsion. It means electron gain enthalpy for the chlorine is more than that of the fluorine. Right? So this is the correct sequence now. So it is A is the correct sequence. Any doubt?
Okay. So then what about bromine, because isn't that in the same situation?
It should be, but it is quite bigger. It also has the D subshell. But as the size increases, what happens? The attraction will decrease.
Right. So this is the smallest size with the. Okay.
So you have to remember this exceptional case. Okay. What is electronegativity?
Electronegativity is like the atom's ability to attract electrons in a shared bond.
Very good, very good. It's a perfectly correct answer. It's the basically tendency to attract shared pair of electrons towards itself. Right?
Yeah.
So which has the highest electronegativity here? Any idea here? Don't give me an idea. Give me an answer with surety.
Well, like from what I've learned, I feel like is oxygen.
Yeah.
Just because like I remember from like I don't like actually know the numbers, but like from like what I remember from the numbers, like oxygen was bigger.
Fine. Means you have just some facts in your mind.
Yeah.
Okay, no problem. Basically, that's what you are here to understand everything clearly, right? Okay, I will help you here. In the periodic table, as you move along a period, the size, you tell me what happened to the size as you move along a period.
The size will decrease.
Right. Yeah. As the size decreases, the attraction for electron will
decrease.
No.
Oh, sorry, increase.
So I can say the electronegativity will increase.
Yeah.
Right? Electronegativity will increase. Now, if I compare these elements in the periodic table, carbon, here the oxygen, right? Magnesium is in toward this side, sulfur is just below the oxygen. This is the relative position of these elements in the periodic table.
Right.
Should I show you that the periodic table here?
I have one.
Okay. This is the carbon here, oxygen here, sulfur, and here the magnesium. Right? I told you as you move along a period, the electronegativity increases, and as you go down the electronegativity will decrease. From here you can judge which is the most electronegative here.
The oxygen.
Of course, oxygen. Yeah, it is small in size. Right? That's how we can come to this conclusion that oxygen is most electronegative element. Right?
Right.
Okay.
What order is increasing oxidizing power?
Yeah. Do you know the meaning of the word here, oxidizing power?
Isn't it like taking away the electrons.
Very good.
Basically.
Yeah, it means the element that takes away the electron from the other one
Yeah.
is a good oxidizing agent. So how does this electron oxidizing power varies in these halogen molecules?
D, we should have like be able to take away the most.
Do you have any particular concept regarding this?
Well, like I feel like wouldn't that be related to electron negativity because it has the most attraction to fluorine?
That's good. That's good. So the D option correct answer, right?
Yeah.
Yeah. Variable valence in general is exhibited by
transition elements.
Yeah, very good. So iron can show +2 and +3.
Yeah.
Manganese can show +2, +3, +4, +5, +6, +7. Right. So they have variable oxidation valency.
Yeah.
Most easily reduced. Most easily reduced. What is meant by the word here? Easily reduced?
Like you would add electrons to it.
It takes up electron easily?
Yeah.
Because reduction is gain of electron, right?
Yes.
So which element will take the electron easily?
Fluorine.
Fluorine. Option A should be the correct
Yeah.
answer. Yeah.
Mm-hmm.
Now you're in flow.
Yeah.
Finally. You will. It is our second class only, right?
Yeah. It's like thank God.
Within like 5-6 classes onwards, you will be in the flow with chemistry.
Yeah.
Don't worry.
Hopefully.
It will be. And more, one thing I would just suggest you to go through all my assignments, whatever I gave you, right? And it will be quite easy for you. It's not a difficult subject at all.
We'll try. Sudden large jump between values of second and third ionization of helium element would be associated with transmutation of
Second and third, big jump. Second and third, big jump.
Wait, isn't C not a real element? Because you need to have two pieces.
Quite very. It shows very less confidence.
Yeah.
Okay. What I do is very simple thing. See, I'll prove this answer here is the A answer, right?
Okay.
Okay. So we are given this electronic configuration here. That is a 1s2, 2s2, 2p6, 3s2. And I am providing delta I H1 and making it an A positive. So it's a 1s2, 2s2, 2p6, 3s1. Is that clear? Now I am providing delta IH2, second enthalpy of ionization. Now it will become 2 positive here. And now it is a 1s2, 2s2 and 2p6. And now when I come to the delta IH3, I have to remove electron from this completely filled electronic configuration.
Right, so that's the biggest.
Yes, the second and third will have the maximum difference in the energy. And that is why my option A is the correct answer.
Okay.
Getting me?
Yeah.
Okay. Highest melting point. Highest melting point.
Doesn't this have to do with kind of like, oh gosh, I don't know what it's called, but like the difference in like the. So would it be the CCO4 because that has the.
Why so? Why so? Why so? Why so?
Because it's the bond is the hardest to break?
In the melting, do we need to break the bond, or we have to separate the molecules?
Separating the
Yeah,
molecules.
yes. So think in these terms.
So then we'd be looking for like dipole
Yeah,
reactions.
now
Right?
you're coming to the point. Yeah, that's good. It means the one which has a stronger intermolecular force of attraction
Right.
will have
So
the
then
melting point. Yeah.
BCO3.
Okay, one thing. If it check, I think it's the answer, the A option, correct answer. I'll justify it, right? Let me justify it. If I talk about the BeCl2, it is like this. And one very good technical term you spoke was the dipole moment, mu, right? And that is this attraction in the opposite direction, and that is why there is a null vector and the dipole moment is equal to 0. BCl3 is a symmetrical molecule like this, so again dipole moment is equal to 0 because it is being pulled from all the directions.
Right.
And carbon tetrachloride is also being pulled from all the directions.
With the same force.
Yeah.
So then LiCl, because it only has one.
Yeah.
And it's
So
okay.
that moment will be 0 here.
Has the largest dipole moment.
But in case of the lithium chloride, the chlorine is pulling electron toward this side. Partial negative, partial positive, and the dipole moment is greater than 0. It means this molecule is polar. Right? It's a polar molecule.
But then isn't this also an ionic compound?
Yeah, it has some ionic character is there.
So then don't ionic things not have dipole moment?
They have polarity.
Okay.
Right? They have polarity, means one ion is negative charge, other is a positive charge.
Okay.
Right? So it's a polar molecule, and so they have a strong intermolecular force of attraction. Strong intermolecular force of attraction. Right? Getting me?
Yeah.
So LiCl will have the highest melting point. Yes, very simple question.
This is a keeping number of valence electrons.
Number of valence electrons?
Yeah.
It means all the elements which have same number of electrons in the outermost shell will be in the same group.
Yeah.
That's good. Okay.
Nitride and lithium nitride is composed of so that would be N3. So then A? 7 protons and 7.
B.
Oh.
I'll tell you how. Right. When I talk about nitride ion, it means I'm talking about the N3 negative ion.
Right? Oh, okay.
So protons are equal to 7 only.
Yeah.
But the total number of electrons are equal to 10. Right?
Yeah.
Okay.
I guess like nitride ion didn't translate to N-3 in my head.
Okay.
Ratio between radii of each.
Leave this question right now. Yeah, come to this one.
Okay. So then
Think logically. no guessing, please.
um, so like the biggest one would have the most electrons in it. So then the most electrons would be the the least amount of electrons is O. So then
Okay,
and then F.
I would suggest you something, right? Do you know the atomic numbers?
O is
8.
8,
F
and
is
then F is
okay.
7.
Do they have the same number of electrons?
No.
No. Okay. Then you find out the nuclear charge per electron in all of these.
Right. So then two. I mean,
what
O is
you
-2.
are supposed to do is, one thing is very clear, that anion is always bigger than the normal atom.
Yeah.
And cation is smaller here, right? If you compare here the F negative and the O2 negative, are these isoelectronic? Don't you think so?
Yes.
Yes. So nuclear charge per electron, find out nuclear charge per electron from among these. Nuclear charge is 9 upon 10 and it's 8 upon 10. It's a 0.9 here and a 0.8 here, right? So which is the higher nuclear charge per electron?
The
fluorine.
Like the point,
fluorine.
yeah.
Higher nuclear charge per electron means more attraction.
Yes, so
more
that means
attraction
a smaller.
yeah, so I can say oxide ion is bigger than the F negative here. Okay, so anions are always bigger than the atom. It means these are greater than the O and F neutral, right?
Yeah.
And now if you compare the oxygen and the fluorine, which is bigger in size?
The oxygen.
How do you know?
Because it has a lesser attraction, so the
don't you think that
electrons will
O
be.
is atomic number is 8 and fluorine is 9?
Yeah.
And they are along a period?
Yep.
So as you move along a period, how does the atomic size vary?
So the atomic size gets smaller.
Yeah, that is the see the correct answer now.
Yeah.
Yeah, that's how you had to decide. That's it.